Okay, so let's see. Continuing on with statics homework, problem 2 of homework 6. All right, so we have another force applied to another pipe in the U-Hart basement, and the force vector is that beautiful thing. And the pipe dimensions are 2.3 meters, 1.2 meters, and 1.9, according to X, Y, and Z. Did I get all that right? Yeah. Okay. And we want to determine the equivalent moment at O due to the applied load using the cross product. Okay, well, let's do it then. So we have page 2 in our Dr. Deal. And this is spring of 21. ES110, and this is homework 6, problem 2. And we have this beautiful thing. Let's see if we can replicate this wonderful thing. Let's see, here's our coordinate system here, and our isometric, quasi-isometric maybe, and we're going to come up. We're going to go over. And then we're going to go over this one. I don't want these to overlap, so I'm going to make it over that way. Yeah, it didn't do a great job. All right, something like that. Okay, and here's my pipe fittings. Right in there, and let's see, here's my X, here's my Z, here's my Y, and see, we got a force, and I didn't bother to try to show you the force. You see, I made him a hat too. Why is that A? Okay, I guess so. Whatever. And there's O. And, okay, so the dimensions. Okay, everything's in the way. Everything's in the way today. I got something, my hair falling out. That's lovely. Let's just be YOA. And how do we do this? Oh, I see. They decided to make this clever thing right here, right? So they decided to come over down to there. I guess it kind of ghosted in, huh? All right, so here is XOA, there to there. And here's Z. How do we do that? And you go, is this worth it? Is this worth it, all the effort to draw the thing out? I think so. It makes you think while you're doing it. Gives you a good feeling of being in control of something. That's the nice looking drawing. Okay, so we have 23I and 19J and minus 13K, and these are kilonewtons. And my other dimensions are XOA 2.3 meters, YOA is 1.2 meters, and ZOA is 1.9 meters. And our find MO, right? So we want to find the reaction, no, the equivalent. Maybe even writing it there, equivalent. just couldn't keep the glasses on the whole time. Look at all the hair. The hair up there. We need a hairnet. All right. So what we want to do is we already have the force. Let's get the R A with respect to O. And that's actually pretty easy to do, right? It's actually, they're all just positive values. It's kind of boring. Should have made it more interesting. Anyway, I think I just made this one because the first one was only like it was just two-dimensional. So this is your first three-dimensional one. So I was trying to keep it simple. So let's see, 2.3i plus 1.2j plus 1.9k, and these are meters. So this equivalent moment that we have that's taking on place here is going to take, oh, I should write out the equation. It usually takes a long thing anyway, so let's do it out here. Our A with respect to O crossed with our F right there, which is going to give us I, J, and K here. And so it's 2.3 because we do the position vector on the second row here, 1.2 and 1.9, and then we take out our negative 23, right? So he's kind of going off in that direction a little bit away. It kind of looks that way. 1.9. Oh, wait, 1.2, so it is going upward, so it looks that way. And then this one actually, I think it should be looking kind of like facing a little bit more that way. What? Dummy. I don't know what I just said right there. 19. There you go. Yes, that's right. Okay, now this one, yeah, negative 30. Okay. Yes, all right. Brain was fried. Okay, so MO over here, and now we take I times the determinant of this guy. All right, so the little determinant is going to be 1.2. Focus. 1.2 times our 19 minus. Why did I do that? What the hey? It's 2.3. No. Okay, I was right. 1.2 crossed with our negative 13. Get your act together, man. And then the 1.9 crossed with the 19, and we got an I. Now here's the minus. Always remember the minus. I always forget the minus. All right, now we're going to do this one, that, and that one to that, right? So 2.3 and a minus 13, and now we go 1.9 and minus 23, and there's J, and I couldn't fit it all onto one line. So I'm going to come down to the next line here, and now we're going to take this crossed with that. So 2.3 and the 19 minus with the 1.2 and minus 23. And these are, and they're going to be kilonewton meters would be what these would be. So let's get this all worked out here. Now we got to go. Now we just got to go through the mathy math, and don't forget that minus when we get over to there, right? I'm counting on you to remind me. All right, so at 1 point, well, turn it back on. 1.2, 13 times, and that's negative, so I made that negative. And they got 19. No, that's 1.9, but I'm going to use 19 next to them anyway. Right? Boom, and we're subtracting it, and so we get a negative 51.7 I. And the next one here, I'm just going to do that negative at the end. 2.3, 13 times, and that's negative. And then 1.9 and 23, and that's negative. So we're going to add that to the negative thing. And we see that we get 13.8, but it was negative. Negative 13.80 J, and then 2.3 and 19, boom, and 1.2 and 23 times, that's negative, so we can add those two together, and we get a 71.30. There it is right there. 71.30 K kilonewton meter. And there's enough right there. We don't have to rewrite this thing out, even though we started to go upwards, right? You see, we got a little slope action going on here. So I'll try to get everybody inside a box. Boom. Yes, yes, a box, a box. Put it in a box. Cool. Another one bites the dust. That was a pretty straightforward one, right? We need more of those. It's only a 10-minute problem. 11 minutes. Call it 11 minutes.